In the third part of this video series on graphics and GUIs, we will first discuss using listeners for radio buttons and checkboxes, and then illustrate the use of these components with an example. We will then define a custom listener and redo the example using that custom listener and explain the benefits of the second approach. We begin with an explanation of how to listen for radio button and checkbox events. Recall first that radio buttons must be grouped using an object of the button group class. No grouping is required, however, for checkboxes. To listen for events of either radio buttons or checkboxes, the item listener interface must be implemented. The item state changed method is called when a radio button or checkbox is changed. It is the only method in the item listener interface, which means that interface is a functional interface. Because it is a functional interface, lambda expressions can be used for the event handlers. Although it is possible to listen for these events, event handling of these controls is not required, and in most cases is not needed. Instead, the state of these buttons can be checked with the isSelected method when another event, like an ordinary button click, occurs. The program example that we will use to illustrate event handling radio buttons is one that allows the user to select the color of a circle using the event handling capabilities of these buttons. It reuses the colorable circle class that we introduced in Part 1. Because the colorable circle class was defined in a different package, we need to import it so that we do not need to qualify it by its package name. Note that we are using an inner class to define the panel that will contain the radio buttons. These three radio buttons provide the choices for the colors that can be selected. Let's scroll down to the constructor of the inner class. First, we must add the three radio buttons to the panel. Then we must create a button group and add them to that group. Finally, we must register the listeners for each of the three radio buttons. Notice that we are able to use lambda expressions for this purpose. In each case, when a radio button is clicked, the change color method of the colorable circle class will be called, and the corresponding color will be passed to it. In the constructor of the outer class, we add the button panel to the left side of the window and the circle panel to the right side. Scrolling down to the main method, we notice that it looks the same as all previous ones. Let's run this program. Notice that when we clicked on each of the radio buttons, the circle was changed to the appropriate color. Now let's explain how custom listeners can be created and redo this example using one. Using a custom listener can make it easier to develop more reusable code. What limits the reusability of the color panel that we developed in the previous example was that it was defined as an inner class of the window class. That was necessary because the event handlers for the radio buttons needed to access the circle object that was defined in the outer class. Like all predefined listeners, a custom listener is defined as an interface. If we include only a single method in it, it will be a functional interface, which will allow us to use lambda expressions for the event handlers. As is true for all predefined listeners, a custom listener specifies which method is called when the event it defines occurs. The method called can optionally be passed information about the event, just as is done with the predefined listener interfaces that typically have a parameter that contains information about the event. Here is the definition of the custom listener interface, color listener. It contains only one method signature, change color, which makes it a functional interface. This class defines the same color panel that we used in the previous example. The one important difference now is that it is no longer declared as an inner class. Consequently, it is no longer tightly coupled to the class in which it was previously nested. There is now one difference in the constructor. The listener for color change events must be passed to the constructor as a parameter. This technique is similar to the approach used for associating the listener for timer events with a timer object. Let's scroll down to the remaining lines of the constructor. These are the modified event handlers for each of the 3 radio buttons. First, notice that because we made the color listener a functional interface, we are able to use lambda expressions to define the event handlers. The one difference now is that the object on which the change color method is invoked is no longer the object's circle as before. Instead, it is whatever object was passed to the constructor. Finally, let's look at the class that defines the window for this program. One difference is that the window now implements the custom listener interface color listener. Scrolling down to the last several statements in the constructor, first notice that when we instantiate the color panel object, we pass in this, which is the window that will be the listener for color change events. Because this class implements the color listener interface, it must override the change color method that will be called when a color change event occurs. This method will then call the change color method of the colorable circle class. This program behaves exactly the same as the version of this program presented earlier, so we will forego running it, but you may want to do so to confirm that fact. Recall that defining this interface allows the color panel to be decoupled from the window class. The benefit to this approach is that the color panel now can be reused by other programs that might require such a control.